The day DARPA banned humans from the warship, naval engineering flipped upside down. No bunks, no bridge, just a 180-foot machine called Defiant, ordered to survive alone. The real enemy is not missiles, but endless storms, corrosion, and failure, threats once fought by sailors, now faced by code and design. Can you really build a warship that wins by not breaking? This is a battle of reliability, not heroics. And what follows is not science fiction, it is the story of how the world's most radical warship is engineered to stay alive when no one is left on board to save it. Strip away every trace of human life. No bunks, no bridge, no galley, not even a coffee maker or a single fire extinguisher, and what is left is pure machine. The No Mars mandate did not just delete the crew, it wiped out every system built to keep people alive, comfortable, or safe at sea. Gone are the passageways sized for boots, the ladders and handrails, the thick doors meant to seal off fire or flooding. There is no need for fresh water tanks, showers, toilets, or the endless miles of piping and wiring that snake through a normal warship just to keep a crew fed, rested, and breathing clean air. With humans banned, all that reclaimed space and weight can be spent on fuel, sensors, and payload. The hull slims down, no wider than the biggest piece of hardware it needs to carry. The deck stays flat and open, ready for whatever modular mission container gets bolted on next. Every cubic foot that once belonged to habitability now serves endurance, range, or combat systems. Power that would have run the galley or air conditioning now feeds the propulsion and electronics. The safety gear, such as life rafts, firefighting systems, and man-overboard nets, disappears and is replaced by layers of redundancy and self-monitoring code. What emerges is not a downsized destroyer or a drone boat with the seats ripped out. It is a vessel designed from scratch to survive without rescue, to keep going when parts fail, and to use every ounce of its build for the mission, not the crew. Only by enforcing this rule, no humans ever, could engineers see how much ship was wasted on us, and how much more it could become when freed from our needs. In a quiet shipyard on Whidbey Island, the rules of naval engineering took physical form. USX Yum. Defiant stretches 180 feet from bow to stern, weighing in at 240 metric tons. A warship that looks almost too lean for its own shadow. There is no superstructure cluttered with windows or ladders, just an open deck and a single mast bristling with antennas. This is not a prototype in theory or a digital rendering. It is welded steel and composite, built by Serco and Nichols Brothers boat builders, completed in early 2025. The hull itself is a statement, every inch shaped by the absence of humans, every compartment carved for machinery, not mariners. Greg Avicula, the program manager at DARPA, stands behind the ship's radical approach. Defiant is a tough little ship and defies the idea that we cannot make a ship that can operate in the challenging environment of the open ocean without people to operate her. His words echo through the yard as the vessel sits ready for sea trials. No handrails or portholes in sight. The construction was as unconventional as the design. 14 workers spent 14 months welding the hull together, skipping the usual maze of crew spaces and safety redundancies. The result is a ship that can be built and maintained in smaller yards, far from billion-dollar naval bases. This is tangible proof of the No Mars vision, a warship that does not just survive without a crew, but is born from that very rule. The next test is whether it can stay alive on its own, far from shore, with no one aboard to fix what breaks. Most warships lose the fight long before enemy missiles arrive. The real enemy is not always a torpedo or a drone swarm. It is the thousand small failures that stalk a ship at sea. Saltwater chews through metal. vibration rattles bolts loose. Electronics drift out of tune, pumps seize, sensors fog up, and corrosion worms its way into every exposed wire. On a normal ship, a sailor spots a leak or a flickering panel and fixes it before it becomes a crisis. But on Defiant, there is no one to hear the warning buzz or tighten the valve. Every storm, every rough patch is a test of whether the ship can keep itself alive. That's where the concept of graceful degradation comes in. Instead of betting everything on perfection, the designers built Defiant to expect trouble. When a component fails, the system does not just shut down. It routes power or control to backups, isolates the fault, and keeps going. The mission continues, even if a thruster, sensor, or computer goes dark. There is no single point of failure that can end the voyage. This is reliability by design, not by luck or quick-thinking crew. The goal is stark. Defiant must operate for up to a year at sea without human help. That means surviving storms, corrosion, vibration, and wear, not just once, but over and over. Every cable, every motor, every circuit is chosen for endurance. Redundant systems and self-checks replace the eyes and hands of a crew. Reliability is not just a metric. It is the difference between a warship that wins by not breaking and one that never comes home. On Defiant, survival is not left to chance or clever sailors. Every major system, including propulsion, power, and control, splits into redundant pathways, each ready to take over if another fails. The ship's brain constantly checks for problems, rerouting around a dead thruster or isolating a faulty circuit. If a pump seizes or a sensor glitches, the mission does not end. The ship adapts, keeps moving, and logs the failure for the next port visit. This is not magic, it is architecture. Distributed systems mean there is no single wire, pipe, or computer that can doom the voyage. If a storm knocks out a generator, backups kick in. If salt water eats through a cable, alternate routes keep the lights on. Maintenance is not a frantic scramble at sea. Instead, Defiant comes home, swaps out entire modules, and heads back out. The design fits Tier 3 shipyards, places that build yachts and tugs, not billion-dollar warships. No need for a specialized naval base or a dock full of technicians. The goal is to maximize days deployed and minimize downtime. In January 2025, Defiant joined the short list of ships to refuel at sea without a single human aboard. The test, in which fuel was pumped from one unmanned vessel to another, proved that endurance is not limited by crew or even by distance. This is a new logistics philosophy. No more waiting for a crew rotation or a port call. Reliability and modular swaps become the backbone of naval power. The ship's ability to operate itself comes from engineering, not wishful thinking. As these vessels multiply, the math of naval warfare changes. Power is measured not just in sailors, but in the days a ship can stay alive, adapt, and keep fighting alone. A decade before Defiant, DARPA launched its first unmanned surface vessel. Sea Hunter, launched in April 2016, stretched 132 feet and looked more like a science project than a warship. It proved a point. A large vessel could cross oceans, hunt submarines, and run for months without a crew. After a series of open ocean trials, Sea Hunter was handed off to the Navy and the Office of Naval Research, making the leap from experiment to an operational testbed. Unlike Defiant, Sea Hunter started as an adapted design, built to be optionally manned, with some crew spaces left intact. It worked, but the architecture still carried the weight of human requirements. NOMARS, which stands for No Manning Required Ship, took the lesson further. To get true reliability and scale, you have to erase the crew entirely and start from a blank sheet. Navy planners now picture a fleet where ships like Defiant serve as loyal wingmen, force multipliers that do not drain the pool of trained sailors. These vessels can fan out as intelligence, surveillance, and reconnaissance pickets, scanning the horizon for threats or act as decoys, drawing enemy fire away from crewed ships. Some will serve as communications relays, knitting together strike groups across vast distances. Others will become payload trucks, hauling sensors or weapons to where they are needed most. Each unmanned ship adds endurance, reach, and resilience without adding berths or mess halls. The Navy's timeline calls for these hybrid fleets, manned and unmanned, working side by 2027. The logic is simple. Scale up combat power, not crew rosters. This is the promise that drives the No Mars program forward, a vision where reliability, autonomy, and logistics set the pace for naval strength, not the number of sailors on board. Defiant isn't a science fiction ghost ship. It's the first warship engineered to survive on reliability, not rescue. Naval power now scales on code, architecture, and logistics, not crew. The real arms race isn't in firepower, but in who can keep their fleet alive without ever setting foot aboard.